Hey folks, how's it going? It's Mr. Murray coming to you with a little do now for Course 1 CP for Friday, May 22nd, 2020. So in this do now, I've got one quadratic in vertex form that you need to convert to standard form, and I have two quadratics in standard form that you need to convert to intercept form. Now, one of these quadratics is a little bit special, and we talked about it during yesterday. Well, not that one in particular, but one similar to it in yesterday's Hangout. I encourage you to watch the video of that if you have a video for your class and you haven't done so already. All right, so please take a moment, pause the video, expand the first, factor the second, the second and the third, and then when you're ready, unpause, and you can see what I got. Okay, so converting to standard form, keeping in mind again, we are in vertex form. What I'm looking to do here is I'm going to use the PEMDAS method, so to speak. So the first thing we want to do here is we want to set up our box. So in this case, because we're expanding, the things go on the outside. Hopefully you used a calculator for this one. That's very important. Okay, because these kinds of numbers, some of them are not, you can't really get it nailed down unless you have a calculator. Okay, would never expect you in your head to be able to calculate a number, okay, like 29 times 29. There's no reason you would need to do that. There's nothing mathematically valuable about that. Okay, so we get n squared, we get 29n, we get 29n, and then on our calculator we do 29 times 29, and we get 841. Now, because there's a number in front of it that's not 1, we drop that number in there, n squared. If you need to, use your calculator to do 29 and 29. That's 58n plus 841 plus 10. Okay, now we distribute. Boom, boom, boom. 2n squared plus 116n plus 1,682 plus 10. And then finally combine 2n squared plus 116n plus 1,692. Now, these numbers seem large, and if you were to make the argument, I would say I don't disagree with you. It's not unreasonable, but remember, any of these big numbers, you have a calculator to help you figure this stuff out. Okay, what I care about is the ideas, the concepts, right? We're using the box to kind of expand things out. We're distributing and using the calculator to help us with that if needed. And then we're adding, right? We're using this process of PEMDAS, exponents, multiplication, addition. All right, on to the next one. We need to convert to intercept form. I chose this one mostly because the a value here was more than 1. I guess that's one reason. But also, it is a prime number. So what I'm going to do is I'm going to open with a box. Up here, I put my 5x squared, and down here, I put my minus 15. Now, 5, like I said, is prime. So the only whole numbers that are positive, we'll work with positives, that are factors of 5 are 1 and itself, right? 1 and 5, right? So I'll put 5x and x, and we can see that by multiplying these two, we get 5x squared. We now need to multiply to get 15. And so what I notice is that I've got two ways to get 15. 1 and 15, or 3 and 5. But I notice that if I put 15 here and I put 3 here, that's a good sign. Now, on the Hangout, one thing we were talking about is thinking through how we find these numbers. And in my attempt to, have a discussion about this, I intentionally would not really try to give you a lot of confirmation because I want you to play around with the numbers on your own. Figuring this stuff out and taking smart guesses is a good thing to do. Another way you can rule out combinations of numbers is to think like this. I talked about in the Hangout this idea that sometimes the three coefficients, the three numbers, so 5 in this case, -74 and -15, sometimes they all have a factor that's in common, okay, that's not 1. So for example, if 74 was 75, all three numbers would be divisible by 5. If that is true, then if you factor it, then that in common number will show up in one of the two factors. Okay? So that's something to think about. But remember, when you have a common factor, you are going to have to take that out every single time. It's an important thing to think about. And before I get to the +3, I don't know why I wrote +3. I think I was thinking about something else when I wrote that. What I meant to write there was +1. So I've got x, I've got -75x, so that adds up to -74. So I get a final answer of 5x plus 1, x minus 15. Last one's a little bit of something special here, and we identified this one over the Hangout because we said, look, standard form is supposed to look like ax squared plus bx plus c. But what happened to b? Well, in this case, b is equal to 0. But more than that, there's something special about this number and this expression. X squared is x times x. And 121, in addition to being 121 times 1, is 11 times 11. So, and this here is a minus, right? So what this is called is a difference of squares. It's a difference because we're subtracting. We have a minus sign. And it's a difference of squares because these are each squares. They're numbers that are equal to something that has been multiplied by itself. In this case, x and x. In this case, 11 and 11. Okay, so when we make a difference of squares, why is this helpful? Well, the reason is because, think about it like this. We know this is x squared and this is -121. Now, these numbers need to add up to 0 because we know that b is equal to 0. But think about it. What kind of numbers are going to add up to 0? Numbers that are opposites of each other. 2 and -2, 5 and -5, 10 and -10, 237,000 and -237,000, right? So we need to know this because if we make one of our numbers equal to 11 and the other equal to -11, because it's a square and it's a negative, we know that it will equal -121, but also because they're opposites of each other, if I set these as x and do them out, because they're opposites, these two will cancel out. So what I get is x minus 11 and x plus 11. And this is a special case called a difference, because we're subtracting, of squares. All right, so what we have here is 3 problems. We have the first one where we are expanding out using the box, multiplying and adding, giving us 2n squared plus 116n plus 1692. We have then a factoring problem where we're having an a value more than 1. So we're quickly just using our logic to guess and check and plug some numbers in. Always remember to list out your factors, which we did, but they're not listed here because I had to erase them to make space from someone else. But just make sure, or something else. But in any case, just make sure you make your factors of the constant. So 15 and 1, 3 and 5. So you know what your options are. And then lastly, we have this difference of squares where we're thinking about making the b cancel out, and we're using the fact that the numbers are opposites, so they cancel out, but then they multiply to the square because the values, their absolute values, are the same. Okay, so again, hopefully you're able to get these right. If so, amazing job. If not, please make sure you try to get a sense of where you might still be getting stuck. Today we're going to mostly be going back and taking a look at stuff that we've been needing to get caught up on. Please, please, please make sure you're staying caught up on work, especially with this Memorial Day weekend coming up, because I'm thinking about the idea of moving on soon, and I don't want anyone to fall behind, especially when we're no longer talking about those same ideas. All right, so best of luck. Keep it up. And remember, you can do it. Until next time, have a wonderful day.